everyone, let's solve this problem. Reverse bits. Reverse bits of a given 32 bits signed integer. So let's understand what they are trying to ask here. So if you see in this question, they have given a number n, which is this, and we have the binary representation of this. So we have to reverse the bits. If you see, it is 0 0 0 0 0 1 1 1 00. It's 0 0 triple 1 and 00 and so on. Like the bits are reversed in the 32 bits signed integer. So they have also specifically mentioned that it's a signed integer and also it has only 32 bits. So now let's try to understand how we can do this. Let's say for example I have a number, let's say 3. Okay, the binary representation of 3 would be this, and we will have 31, 0 to 31, because there are 32 bits. So now we have to reverse it. So if we have to reverse it, we will bring 1, this one here, and rest all are 0. Basically we will bring all the digits in the reverse order. So we have to accomplish this. For us to do this, we have to first know the, let's say this is the 0th position, let's say this is ith position, whatever we consider that is an ith position. In this case we will get the bit, so I will just do AND with this bit. So I'll get if this is 0 or not. So if I do AND, if it is 1 I'll get 1, if it is 0 I'll get 0. So I got 1. Now I have to shift it. So if I'm at 0th position, if I have to shift it to 31st bit, what will I have to do? I have to do a left shift of 31, right? That's when it will go to 31st. So this is nothing but a bit. It can be either 0 or 1. So I have to do left shift of 31 times here in this case. So it will go to the 31st position and it will be placed here. Now I will have to take the next value. Next value is first position index. So the value is 1. So what can I do is, I have already processed this, so I can do a right shift and all these indexes will move 31, and now again I can do AND with 1 and I'll get the bit is 1. Now I am at the first position, though I have shifted the position of bits, but I remains 1 which I have taken. So I have to shift it to 30th position now. So it is nothing but 31 minus I. Then I'll get 1 at the 30th position and so on. So that is how we are going to do. So the logic would be, for every bit, I is a bit position, I will do n right shift of I to get the bit, and also I have to do AND with 1. So basically for every bit position I am bringing that position to the 0th index, and then I am doing AND so that I'll get the bit. Once I get the bit, I will just have to do result or with the bit left shifted 31 minus I times. So this is the logic. So let's try to write it. So initially we have result which is 0, then we iterate over all the bit positions, and bit positions can go from 0 till less than 32 because there are 32 bits, and the indexes will be from, or bit positions will be from 0 to 31. Once we get this, we have to get the bit either 0 or 1. For that, what we are doing, we are right shifting the number with I and we are adding it with 1. Once we get it, we are going to shift the bit, left shift the bit with 31 minus ith position, whatever we have done so far, and this will place the bit in the right position in the reversing of the bits. So now we have to return the result. Submit it. Let's submit it. Okay, now let's also understand the time and space complexity of this. So time complexity is 32 big of 32, which is nothing but a constant time. Like no matter what the n is, it will always be 32 times, so it is considered as big of constant time, and the space or complexity is also big of constant, because we just are using result and nothing else is being used here, so it would be constant, so nothing but big of 1, right? I hope the solution is clear. Thank you.